Okay, so today's lesson, I'm going to go back to using my smartboard again. The problem, of course, is the lighting absolutely stinks over here, so you don't get to see my beautiful face as well. But it's just because we're doing graphing and whatnot, it's easier to do that, of course, here than it would be on a whiteboard. So you'll just have to focus on here the best you can, and hopefully this will all work out. So we are looking at 7.1. We are looking at graphing in slope-intercept form. And of course, we're going to be using the textbook as a guide for this. So instead of doing the examples they give you, what I'm going to do to help us follow along best is I'm going to actually follow the assignment at the end of 7.1, the practice questions. And we're not going to do all of them. I'm going to do 1, 2, 3, 5, 8, 9, 10, and 13. Again, you should have already worked through these again as I requested. Before you move to the assignment, you should be trying through the questions in there because they're very similar to the assignment questions. There's an answer key in the back to help you work through these questions, and that's just going to make your life a whole lot better if you do the practice questions first. So make sure you are in fact doing those. I'm assuming you did, and now I'm going to help you work through some of those to help you with the assignment. As we're working through this, of course, it's good to remember what slope-intercept form is, which is our classic y equals mx plus b format, where m is the slope. It's got a lot of other names. Rate of change is another name that goes by constantly, right? So, I mean, 50 kilometers an hour is a rate of change. It's going to cost me $1 for every bag of chips I want to buy. That's a rate of change. So rate of change can apply to a lot of things. This is best to remember to say this every time as you're going: rise over run, rise over run. How far up and down you go over how far left and right you're going to go. So that's going to be important. And we're always going to put this in terms of reading, right, from left to right. So rise to run is always talking also as we move from the left to the right. A rise goes up, or a rise can go down, which would be a negative value. And the run is going to be that horizontal movement. The B, of course, is our y-intercept, which is short, right, for the y-axis intercept. Where do we hit the y-axis? I often refer to this as our starting point when we're looking at graphing equations, because the starting point is going to be when our slope is 0, right? If we draw our common everyday graph where the bottom left corner is 0.00, right, then it's going to be where are we starting from on this graph. That is why I call it the starting point. If we were graphing a standard XY graph, right, the y-intercept is just saying where are we going to hit the y-axis, right? Positive y-intercept value there, right? A negative y-intercept would be below the x-axis. The key with the y-intercept, this is going to be when x equals 0. That's going to tell us when the y-intercept occurs. So a good little intro warm-up there as we start moving on, and we're going to take a look at the first few questions here. So 1, 2, 3. 1 is very straightforward. It's just understanding, of course, again, I'll put it down. We are in y equals mx plus b format. M is slope, b is y-intercept, and they're asking for the slope and y-intercept of each line. What is the m value of each line? Of course, the slope is the one that's attached to the x value. So negative 5x, my slope is just negative 5. Y equals x minus 7. What's the coefficient here? This is going to actually be 1. We don't write 1x's. That gets too complicated, but we have to remember that 1 is there. So my m value here is 1. The last one here, I don't have an x value. Oh, so I don't have a slope. And yes, we can show that. There is 0 slope. Right? We could write this as y equals 0x minus 3. But why would we write 0x? If x could be anything times 0, it's always going to be 0. It's not there. So we don't write it. Those are our m values. To find the b values, this y-intercept, we're looking for the constant in our equation, the number without a variable. Right up here, plus 4 is the constant. Yes, the plus negative, right? Positive, negative, plus minus is important, right? Negative 7 is our y-intercept, and here negative 3. And that will be our y-intercept. Which is going to take us to question number 2. So I'm going to do this one up real quick, and then we can actually get to the graphing, which is going to be the important part of what we're doing here. So consider the line y equals negative 3x plus 2. What are the slope and y-intercept of the line, which is what we just completed. So so the m is our slope, the b is our y-intercept, mx plus b. So my slope is negative 3. My y-intercept is the plus 2. Part B of the question is asking me, explain how you could sketch the graph of the line, right? So again, this is going to be up to you to explain how you want to. The textbook should have an explanation of how they would do it. And again, that should help you with completing the actual assignment. Basically, I'm just going to write down something, right? I am going to start with a properly labeled XY graph. I'm going to find my y-intercept, so I'm going to find my plus 2, and I'm going to apply the appropriate slope to it. This is a negative 3, so it's going to go down, right? So it's going to end up something resembling this. The explanation is just to kind of warm us up. What's going to be really important, of course, is going to be our next question, question 3, which will actually be some graphing. So I'm going to take a quick look at that here in just a moment. Okay, so got some graphs here. If you need graph paper, let me know. We could post it online, whatever we need. But we need a proper XY graph. So I have one that's got like a darkened XY. When we're graphing, we need properly labeled graphs. So that's very important. So I would have this as my X and Y axis, right? So that's important to label. Arrowheads on my axes, because the axis, we got to show that just because my graph ends doesn't mean the graph ends. It goes on forever. Arrowheads. There's going to be marks associated when you do any math class for including arrowheads on your proper diagrams. We need a scale that's going to work here. Of course, for our intro here, graphing, usually a 10 by 10 scale works. I'm not going to clutter this up by writing 1, 2, 3, 4, 5. That takes forever. So we should do at least every second one, maybe every third one, every fourth one, every fifth, but just something where we space it out a little. So if I do every second one here, this would be 2, 4, 6, 8. My graph should be complete, so I should go backwards as well. Negative 2, negative 4. Really? Negative 6. Going up, of course, 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, and negative 10. So I got my labeled graph. Now I'm actually going to start looking at graphing this. So in the equation of y equals 2x minus 3, how am I going to graph this? So this is what the answer number 2 was trying to get into. It's a little easier to see it straightforward when I'm actually graphing. So y equals 2x minus 3. First thing I'm always going to look for is where is my y-intercept? That's going to tell me where I hit the y-axis. The vertical line is at negative 3, and I'm going to put a dot on that point. So that's my starting point. Then I'm going to look at the slope. So my slope is m equals 2. So does this have a rise over run kind of feel to it, right? So that's going to be rise over run. It doesn't appear that I have a denominator, but again, that's one of these invisible denominators that's always there that we don't write because it's cluttering. Is actually 2 over 1. It does not change the value. So this is going to have a rise of 2 and a run of 1. So that's all I'm going to do is start at my negative 3 y-intercept. I'm going to rise 2, run 1, rise 2, run 1, rise 2, run 1, and 1, 2, 1, rise 2, run 1, rise 2, run 1. And I can keep going throughout the entire graph. Right? Now this is going to be a positive 2. If I have negative 2 over negative 1, you can do the math. It still comes out as positive. But you got to look at going backwards, right? If I go down 2 and back 1, right, that's still rising 2 and running 1 to get there. So we can continue this right through our graph. So I have all the plot points I need. I can now use a ruler, and I can't use a ruler on a smartboard because otherwise it interferes with my marker. So please don't do what I do. Use a ruler. Make sure you make it look nice. And we are going to connect the dots with a straight line. And I'm going to put arrowheads, right? So I'm going to not just sit there and I'm not going to have a line that's shortened to the point right there. I need to actually draw my line right through my entire graph, because this line continues infinitely. It goes forever in the upright direction. It goes forever in the bottom right. So I'm going to use the entire graph, and I'm going to put the arrowheads to show that it does continue moving. Just because my graph stops doesn't mean the line stops. So very important stuff for mathematics and graphing. And there we go. I have successfully graphed y equals 2x minus 3. So what I'm going to do for this is, like I usually try to say ace the questions, the practice ones, so that's what I'm doing here. I'm not going to do every one. I'm going to do A, C, and E in the examples. So let's look at 3C. If I have to graph y equals negative x plus 1, how am I going to do this? Again, I got to start with my axes. Just to try and make it a little easier, maybe I'll label every third line. So I have a properly labeled graph ready to go. Now I got to just graph the point, negative x plus 1. So my first point, of course, my y-axis is the plus 1. There's my y-intercept going. Now my slope of negative x. Again, we've got to remember that there's always a coefficient of 1 there. So that's actually negative 1. What's the denominator on this? If it's not showing, there's still a denominator of 1. So it's negative 1 over 1. I'm rising negative 1, running 1. So I'm not rising, I'm dropping 1, running 1. Dropping 1, running 1. And we can graph that. So down 1, over 1. Drop 1, over 1. And so on and so forth. Right? The same thing if I was to go backwards. I could apply that negative to the denominator and leave the numerator positive. It still works out to a negative 1 if I have 1 over negative 1. So I can rise 1, run backwards 1, and so on and so forth. So that's a slope of negative 1. Ruler, connect the dots, arrowheads. My graph is complete. One more graph. Y equals negative 3/4 x plus 2. Same process. Let's make her pretty. And there we go. My points are plotted. I drop my marker. So my slope m, negative 3/4. My y-intercept plus 2. Start with the y-intercept. And from there, my slope is negative 3 over 4. So I'm going to rise negative 3, run 4. So from here, rise negative 3, drop 3, 1, 2, 3, run 4, 1, 2, 3, 4. 1, 2, 3 down, 1, 2, 3, 4 over. I can flip where that negative is, but I can still work in the backwards direction, right? So this time I'm going to rise 3, but run 1, 2, 3, 4 backwards. I'm going to be up the chart. I got enough points to make a straight line, of course. And I'll put my ruler on there. And there it is. So it makes sense that it is a negative slope, so it's going down from left to right because it's negative. My rise is 3 for every 4 that it runs. And that's it. That's how we graph our lines. So we will take a skip of number 4, I believe. I'm just looking at my notes real quick. And I think we're jumping to number 5, which is now going to ask us to express each equation. So we're going to take a value that is not in y equals mx slope-intercept form, and we're going to put it in slope-intercept form. So, putting in slope-intercept form as a reminder for myself, I'm going to write that down up here. Y equals mx plus b is the format I need this to be in. So y has got to be a coefficient of 1, and then it doesn't matter with m and b, we just got to move them onto the opposite side of the equation. So of course, because I'm moving things, I can move things left, I can move things right just by adding and subtracting. I'm going to use the y to determine which way I move everything. Here I have a positive y already on the left, so I want to leave that there, and I want to move everything else to the right. So then I'll go from here and I'll say, okay, I need to subtract 2x here to get rid of that, and I need to subtract 2x on the right side. There we go. I have now y equals 6 minus 2x, which is acceptable, but to make things clear, to be in proper y equals mx plus b form, we should write that x variable first, and then the 6 last. So we do need to move these around to y equals negative 2x plus 6. It's that simple. Here, if I look at the one, if I go down, not going to C, but if I jump to E here next, I'm looking at 7x minus y plus 9 equals 0. I have a negative y this time. Now I can sit there and I can move everything to the right, keep the y on the left, and I got to get rid of the negative. Myself, I like to move the y. So if I want to move that y to make it positive, because if I add y to this side, I can add y to this side. That crosses that off, and I end up with 7x plus 9 equals y. My y is already positive. Everything else works out. I can rewrite this in the proper way. To flip it now, instead of writing 7x plus 9 equals y, I can write y equals 7x plus 9, and I am in y equals mx plus b format. We might run into something a little trickier, but it's actually easier than you think here. In the next example, 5x plus 6y equals 8, positive y where it is, move anything else. Subtract the 5x from this side, subtract the 5x from this side. This becomes 6y equals, I'm going to put the negative 5, actually, yeah. I'm going to put the negative 5x. Now I know it needs to be first. There we go. Now I'm not quite in y equals mx plus b format yet because my y has a coefficient of 6. So how do I do this? I got to divide left side and right side both by a value to make that equal to 1, and that's going to of course be 6. So basically if I can divide the entire equation, both left and right side, by 6, that will give me my final answer. So 6y divided by 6 is just y. Negative 5 divided by 6, it sounds complicated, but why don't we just leave it like that? Negative 5 sixths. X plus 8 divided by 6, I can write that as plus 8 sixths. Am I done yet? No, we do need to simplify all of our slopes and all of our y. We need simplified fractions always when we're writing an answer. So the y is simplified. The 5/6 is simplified. We don't want to write things in mixed fraction format. There's still work to be done from this. We're going to leave it be. So negative 5/6x. Can we simplify 8/6? Yes, we can. They're both even numbers. Plus 4/3. Now, I'm okay with us leaving the answer like this. Like I say, leave it as an improper fraction I'm fine with, as long as you can graph that properly, right? Can you graph 4/3? Do you know that it actually converts to 1 and 1/3? Great. If you want to write this as the same thing, you can do so, but I will accept both of these answers. It's just often in math we're not quite done here. It's just when you have your final answer that you were looking for, then you can write in mixed fractions. But often in math, this is not going to be our endpoint. We're going to continue working from here. So unless I'm going to graph this and confuse myself, I will leave it as the top one here. Easier for me anyway, and it's easier to continue working with. So that's question number 5, and that is converting formulas into y equals mx plus b form. The next thing here is we're going to take some graphs and we're going to come up with the equation for it. So I only have, I think, the first 4 here for question 8 under your textbook there. I have A, B, C, and D. So again, as long as we know we want to be in slope-intercept form, means we want to be in y equals mx plus b form. So we need to find 2 things. We need to find what is the m value and what is the b value. This should be very easy for the b value, right? B value is y, and where does this line hit our y-intercept? And it's right there. It's at 4. How do we find the slope? There's a formula we can use to find slope. We can use that, or we can just use our common sense. I'm going to look for every point on this graph where it hits a whole number intersection right on, right? So if I go down this line, I follow. It's not going to be until the x-axis is the next point. Follow it down. At the -4 here, there's a point. And I found points that are equidistant apart here. What I'm going to do for the slope is to get from one point to the next, how far do I have to rise? How far do I have to run? Right, I can go up here. So if I go from point 1 to point 3, I'm going up 1, 2, 3, 4, 5, 6, 7, 8. I'm rising 8. And I'm running 1, 2 to get there. That will simplify to 4/1 or just 4. If I use 2 proper points in a row, I can see going from point 1 to point 2, I'm going up 1, 2, 3, 4, and over 1. I'm going to get the same answer every time as long as I simplify properly. So I have an m value of 4, I found a b value of 4, so that pretty much sums it up for me. Formula for this line is just that, y equals mx, so 4x plus 4. That's it. So with that, I can probably work through these next ones a little bit faster here. Y equals mx plus b, so I'm looking for my m value. I'm looking for a b value. B value, very easy, right there, is -1. My m value, I'm just going to look for these, right when the line hits those whole number intersections, which is going to be right here and right here. That'll be right here, going backwards here, and this point here. So I have all these equally equidistant points. They look spaced evenly. So how far do I have to rise and run to get from each point to the next? Well, say if I take this one here, I have to go down 1, and I have to go over 1, 2. So I have to rise -1, I have to run 2. That gives me an m value of -1/2. Now I have my equation ready to go. This is just y equals -1/2x minus 1. I have made that equation from the line. Very straightforward. Here we go. So this is going to have to be y equals mx plus b format. So y equals m. I got a point here. Looks like a point there. Yep, following a nice pattern here. So y equals, what's my slope? from each point, I'm dropping 2 and over 1. So negative 2 over 1. Do I need the 1? No. Ugly, ugly, so let's get rid of it. So negative 2x. My y-intercept was up here at the 6. Y equals negative 2x plus 6. Come to my next one here. I got a point here, 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 probably right in the corner. So again, formula y equals. I'm getting good at these. I don't need to do these b first. I can just go, right? 2 points. Rises 1, 2, runs 1, 2, 3. So 2/3 x. And I hit the y-intercept at 4, so plus 4. Real quick, real simple. So that is question number 8, which is looking for the equations. Questions 9 and 10, very, very similar questions, just a little bit of algebra we need to do, and it's just basic algebra. So consider the equation y equals 3x plus b. What is each value of b if a graph of the line passes through each point? So they're saying here's a point 4, 9, which is on that line, right? And this is in reference to an x and a y location that occurs on that line. So I start with this. The equation is y equals 3x plus b, and I'm trying to solve for b. Well, they gave us an x and a y value to substitute in. Very straightforward, right? So y equals 9, x is 4, so 9 equals 3 times 4 plus b. 9 equals 12 plus b. Subtract 12 from both sides. Negative 3 equals b, or b equals negative 3. And just like that, we're done. Same thing here, right? Y equals 3x plus b, where my x is negative 4, my y is 6. So 6 equals 3 times negative 4 plus b. 6 equals negative 12 plus b. Add 12 to both sides, and 18 equals b, or b equals 18. When we go to the next question, number 10, we're getting the exact same setup. Now we're just looking for a separate value, mx minus 2, so we're looking for the m value. So y equals mx minus 2. What is the slope? So we have y is 1, so 1 equals m times 3, which x is 3, minus 2. I can add 2 to both sides, right? So 3 equals 3m. Divide both sides by 3, and 1 equals m, or m equals 1. We just found the slope. We had the line, the equation, we had a point. We can use it backwards to solve for that missing variable. Last one real quick. Here's my x and my y. Y equals mx minus 2, or 8 equals m times negative 2 minus 2. Add 2 to both sides to get rid of that one. So 10 equals m times negative 2 is negative 2m. I'm going to divide everything by negative 2, so negative 5 equals m, of course, or m equals negative 5. So that is a great question. And it's just using the information we have to solve for a missing piece of information. Ooh, lunchtime. I will probably take a lunch break when I come back. You won't notice the difference, of course. I will work through question 13, and we will look at writing equations from information given. Again, remember with this, we are looking for a rate of change and a starting point, and we will talk about that for me in an hour, for you almost instantaneously. Okay, so I came back from lunch just in time to finish up this last question for us here. So I'm just looking at 13, which is going to give us a few scenarios, and we got to come up with the equation to represent this. And of course, we are going to do these equations in the y equals mx plus b format. which we're familiar with, but then we're going to have to change our variables. While they're saying y and x, we're going to have to change it to whatever they place on us. Again, just a variable is a variable. It doesn't really matter, but for ease of use, right? So in this question here, so what we're going to have to look at before we can make an equation is we need to find out what is the slope and what is the y-intercept. So in this context here, the cost C to make N students to the theater, or to take N students to the theater, is $300 to rent the bus and $6.25 per ticket. So, right, our slope is our rate of change. So then there's going to be the easiest one to find in a question is the slope. What is the rate of change? Well, we could read this at $6.25 per ticket. So that means that is a rate of change. The number of tickets and the rate go hand in hand, and the word per is even in there. So my slope is 625. My y-intercept is going to be my starting point. If no tickets were purchased, how much would this trip cost us? Well, it's $300 to rent the bus regardless of the number of students. So even if students was 0, it would still cost us $300. That is our starting point. So that would be my y-intercept. So to put this in y equals mx plus b format is going to be y equals our slope of 625 per x plus the 300. Now they're asking us to do this in terms of cost and the number of students that we need to purchase tickets for. So that can just be followed carefully. So what are we totally looking for? The cost. That would make sense to put that for the y, because the cost will depend on, right, so dependent, independent, the number of students, n, so 625 times the n number of students plus 300. And there is our formula for this scenario. Then later on, they can ask us questions. They can say, well, what would the cost be if there was 50 students, right? So if n equals 50, we could plug this in the cost with 625 times 50 students plus the 300. We can then solve the problem just by substituting in for n. If they give us another scenario, what if the total cost came out to $850? How many students did we take? And again, it's the same thing that we could do with this one. Now we know the total cost is $850. It's going to equal 625 times n plus 300. And we can use our equation to find out how many students went if our total cost was $850. They're not asking us to do that, but I'm just showing you we can. So ignore that for now. So let's go to 13b. The taxi fee T is $3.60 to start, plus, see, it even says to start, that helps us out, plus $1.48 for each. That sounds like a rate for each kilometer traveled, which they're calling X. So again, we need an M value, we need a B value. They said $3.60 to start, and I said our y-intercept is our starting point, so they really gave that to us. They're saying $1.48 for each kilometer. As soon as they're saying per, saying for each, every, this is going to give us our slope value. Our rate of change is $1.48 for each kilometer. We have an M, we have a B. We just need to plug this in our y equals mx plus b. So y equals $1.48x plus 360. The only thing we got to do now is put this in the terms of the variables they gave us, where they said the taxi fee, the total taxi fee T, so T equals, and they said label this one X, so $1.48 per kilometer, we're leaving this $1.48X plus. And just like that, we have created the equation that we can then use to solve further math problems. For C, the wording, again, sometimes the wording can be confusing. This one, not a problem to work through, but be careful. The wording was a little tricky. We are still looking for a starting point. We are still looking for rate of change. So we're looking for a slope, rate of change, And our starting point. So a rewritable Blu-ray disc has 1024 megabytes of data already stored on it. That's a good starting point. When new data is added to the disk, the total data, D, that's going to be our Y, in megabytes stored on the disk at time T, which will be our X, increases at a rate of, and they even give us the word rate right in there, 54 megabytes per second. So our slope is 54. So the Y is our set of the total data. It's going to be 54 times, which normally are X, but they are calling, what would they say here? Stored on new data is out to the disk, the total D in megabytes stored on the disk at time T. So 54 times T plus 1024. Formula is made. I like these questions myself, so if you're in my classroom and we have a test or something coming, review questions coming up, these are the ones I like, because we got to be careful with the wording. Start the same way. I'm looking for a rate. I'm looking for a starting point. A water delivery truck is filling the water tank of Simone's house. The truck arrived with 2,500 liters of water. Sounds like a starting point to me. The number of liters of water, L, remaining in the truck at the time of T minutes, it decreases at a rate of 120 liters per minute. So it's telling us it started with, it arrived with 2,500 liters. It's saying the rate is 120 liters per minute, but again, this is the reason I like these ones, is it decreases at a rate of 120 liters per minute. So we got to show a decrease by saying minus 120 liters per minute. So again, how many minutes will it take to empty the tank? That kind of thing. We can go from there. We put this in y equals mx plus b format. Y equals negative 120x plus 2,500. And then we just got to put it in terms of the variables they would like us to use. The total water, L, minus 120, that's liters per minute, which is a matter of times, T plus 2,500. And that is that. So that will hopefully get you through 7.1, and make sure you give these shots a question. Make sure you look at the other ones. Right, I did some of the questions on all of them, so try them on your own. Check the answer key in the back. Make sure you're getting the correct answer, and then go to the assignment and do your best to work through that. If you have any problems, make sure you email or call me when you can, and we'll be talking at you soon. Thank you.